Hello and welcome to the TechBrain channel. In this video, we discuss how to apply the attribute design pattern when modeling documents in MongoDB. Let's say that I'm trying to keep track of products within my catalog. My products are represented by a document that looks exactly like what we see here. We've got an SKU, and then we've got a series of attributes. These attributes describe features about this product. As you can see, I've got a camera, I've got storage, make, model. So if I store this in my database, which I will do, I'll take this code and then run it here. Let me clear all that. And first of all, just to make sure I'm starting from a clean slate, I'll do a drop that, and paste that there. So that is my document. I've got an SKU, a SKU, attributes which describe features about this product, and then I insert that into my collection. A few questions will arise from this kind of model. Firstly, what kind of indexes would I need to be able to support efficient querying? If I get new products coming in with features that I haven't seen before, what does that mean for my existing index? Let's take a look. So my query to find a document in this collection will look something like that. db.products.find. I specify the path to the attribute I'm looking for, and I get my result back. But suppose I'm also trying to find a feature called storage. Similarly, I can have a query where I want to find camera and maybe storage. So storage, we can set the storage to maybe 256, and we get the product back. The implication of this design is that I'll need an index for each of the fields that I search by. So potentially I could end up with a lot of indexes. It is not possible well, I could actually create compound indexes for the various combinations that I would be searching for, but that's more indexes within my design. More indexes doesn't necessarily lead to better performance. In fact, it leads to a degradation in performance because with any index that I add, it will need to be updated, it will need to be maintained, it will need resources. So what is a more efficient design? An alternative to this schema that I had before is what we see here. In this schema, what we've done is introduced a field K, call it the key, which references the feature, and then a value that references what was previously the data for the feature. So with this alternative schema, it will be easier for me to create indexes that allow me to search across all these attributes. I'll end up with fewer indexes. Fewer indexes, generally a good thing. Too many indexes, not so good on performance. Let's try this alternative schema and see the indexes that we end up with. So we insert our product, and if I look in products, this is what we get. So we now have key and corresponding value, so essentially key value pairs that represent the features of this product here. If I would like to search for a feature, a complete feature, I can create an index on K and V. Let's say that I'm searching for a feature called make. So find me all the products where the make is Apple. That query will look something like this. So I can copy that bit there and say that I have a filter or a query, paste it there, So that's my filter, and it looks something like that. So I can then go to products, do a find, and pass the filter in. But the filter is coming off the attribute, so I need to do something like that. So where attribute is equal to that filter, and I get my document back. Okay, so it's actually attributes. So put that there, so I get my result back. So attributes is equal to filter, we get our results back. But as expected, this query hasn't been indexed, and I should get a call scan. So I get a call scan as we see there, not great. So let me create an index. I index definition for this query that allows me to query by key and value will look something along these lines. So I'll put my index definition here. So say we've got attributes, okay, and we say that, and also for the value, and we say something along these lines. So this is my index definition. The keys ascending as well as the values ascending. So let's create the index. So we'll say db dot products and create index. We pass the index definition in. We've got our index created. Now let me rerun the query that I had before. So we had the filter where we were looking for make is equal to Apple. Let's see if that uses an index. So that was db.products.find, and we can see that this query does not use an index. Let's create an index to support our query. So the index that I create is an index on attributes ascending. So once that index is created, I can then rerun my query. So this is a query where we're looking for a key and value combination. Key was make, value was Apple. Let's see whether that uses an index. It does. I can then change my filter. I could look for something like make, or rather key is equal to camera. That's the feature I'm looking for. Let's see what index this will use. It will use the same index. So you can see how this pattern allows me to use the same index regardless of the feature that I'm looking for. So I think we had a value of something like 10 megapixels. I'll just remind myself what that value was. So it was 10 megapixels. So say 10 megapixels. So that's my filter. So let me rerun the query. And as we see here, we're using an index. You can see an index scan stage that's taking advantage of the index that we've just created on the attributes array. Suppose I'd like to query for specific features, specific feature and value combination. In that case, my query will probably look something like this. Let me type it here. So we'll say products find where k dot, in fact, attributes dot k is equal to maybe storage. Suppose I wanted to find something along these lines. Storage with what value? So we can say again attributes dot value being equal to that value in the document. So it is actually possible for me to search like that. And what index is going to support this query here? If we look at the fields we've referenced here, it's attributes.k and attributes.value. This means that I need an index on these fields. So I'll create my index referencing that field there. So that'll be 1, and also reference this other field. So essentially, I create a compound index, and that will be ascending as well. So this query here will be supported by that index. So let's get our index created first. So I will create that index. So get rid of all this. Our index has been created, and let's perform our query. So our query returns the document that we want, and let's see whether that is using an index. So say explain with query planner. And when we look through here, we can see that the index it's using is an index on attributes key and attributes value. So again, we can see the efficiencies, the improvements that we've got in applying the attribute pattern as compared to what we had earlier. So this offers us a lot more flexibility and better organization of our indexes. Less maintenance as well. So that's the attribute design pattern. So the attribute design pattern is going to be extremely useful if I need to store flexible and dynamic sets of attributes as we saw from those demos. It avoids creating separate fields for every possible attribute, something that would just lead to performance issues down the line. And as you saw, I was able to store my attributes in a single embedded array. And this allowed for the schema to be more flexible and adaptable to change. So where can we find the attribute design pattern being used? It will be common in things like product catalogs. So within a product catalog, you'd like to store information or specifications about the various products. Also, you could find it in a database that stores user profiles. Each user might have a different set of features, i.e. profile information. You could also find the attribute design pattern useful if you handle IoT data, where a sensor might send different types of data over time, and this data needs to be stored dynamically. A key feature that we made use of in those demos was this idea of a key value pair. Each attribute is identified as a key, and the corresponding value holds the attribute data. The indexing approaches that we saw, we could index either by the attribute field, which was the array, or we could actually index by the fields in the subdocument within the array. Thank you for watching. Until next time, bye bye.